right? So indeed x equals 0, and then this equation has two solutions. Positive the square root of 3 and negative the square root of 3. Back to my table. Okay, so 0 here, negative the square root of 3, because it's between these two. Be very careful. These have to be all these in order, in the ascending order. And the square root of 3. Yes, I have to determine these values. So the top is the square root of 3, and the denominator is 4. So negative the square root of 3 over 4, and the same thing here, but with positive. Okay, now I need to study the sign. And after I study the sign of the second derivative, the table is complete. Nothing else needs to be there. Okay, so let's go to the second derivative. Again, power 3 is dangerous, but x squared plus 1 is always positive, so I'm not going to worry about it. But power 3 is no guarantee plus or minus, but it can be plus or minus, but because x squared plus 1 is positive, power 3 doesn't matter anymore. Good, so I need to find a sign to the left of negative the square root of 3, like negative 10. So please plug in negative 10, negative 10, negative 10, and tell me the sign. So obviously this is positive because it's 100 minus 3, but the negative gives us a negative. Now if I plug in negative 1, this is negative and this is negative. And if I plug in 1, I have negative. And if I plug in 10, I have positive. So here's what the second derivative tells us. Also, what type of point is negative the square root of 3, comma, negative the square root of 3 over 4? Also 0, comma 0. And also the square root of 3, comma, the square root of 3 over 4. What are all these three?
The inflection points.
IP is very good, awesome. Good. I know I have 2 minutes. I'm going to try and graph it in 2 minutes. And that's my page 11. Of course, if you have to go, you have to go. But since I'm here, even if you ask me to graph it again, with pleasure, I will graph it again next time. But I would like to finish it. Okay. Nothing means anything anymore except this. I don't care about anything but my table. All the rest of the work is just gibberish. It doesn't mean anything anymore. Okay. I don't know what this value is. I'm just going to say it's close to -1. I have to approximate it, but I just don't want to hold you. Okay. So this is -1, -2, +1, +2, and -1, 1. Okay. So the horizontal asymptote is this. I don't have to graph it again because it's the x-axis. Okay, so -3, comma, roughly -1. So somewhere here. I'm plotting the points first. -1, -1/2. Or maybe I should use a different color. Okay, 0, 0. And of course, we should talk about the symmetry, but that's okay for now. And this is somewhere here. Okay. So the function opens down, coming from the horizontal asymptote to an inflection point. Fine. down, decreasing from 0 to this point. Where it changes concavity, it opens up and it starts increasing. So just to make sure, I just want to divide the square root of 3 by 4. Ah, it's smaller than 1/2. So in that case, it's over. Yeah, that's good. Just to make sure. So this point is lower. That's very important. So this point is higher. Okay. I should have approximated it initially. Because negative 0.43 and negative 0.5 are different. Okay, good. So this is lower because it continues to decrease. Obviously, it's clear. Okay, so then it changes concavity. It starts opening up, and it reaches a local minimum. It continues to increase to this point of inflection 0, 0. And then it changes concavity. It goes to a maximum. It continues to the inflection point, the square root of 3, the square root of 3 over 4, changes concavity, opening up, approaching the horizontal asymptote. And here's the graph of the function x over x squared plus 1. I don't want to throw this away and not scan it. And that's it.